Okay, year 11, I'm going to go through the last bit of trigonometry, which is the area of a sector. Now, a sector is just like a slice of pie, slice of cake, and it's pretty easy to do the proof for this. Now, they do a proof over here, which is all well and good and reasonable, uses the ratio of the sector to the area of a circle, but we can do an easier proof. And watch this, it's quite simple when you do it like this. So normally when you would do the area of part of a circle, you'd go theta on 360 times pi r squared, because that's a fraction of the circle. But we're dealing with radians, so it's going to be theta. And all the way around the circle is 2 pi, because remember, pi equals 180. So 2 pi equals 360 when we're in radians. Okay, so the area of the sector equals the theta, which is now in radians. I'll put a little c to indicate it's in radians, times pi r squared. Now, the pi's will cancel, which leaves me with theta times r squared all over 2, which if I take the half out the front and swap the position of the r squared and the theta, I get half r squared theta, which is the formula which you get given on your formula sheet. Let's go and have a look and make sure we can see it. And here it is, just here. But remember, that only works when theta is in radians. Okay? When theta is in radians. Well, let's go back and now apply this here. And this is pretty easy. Come on, close. Right. Gee, that took some time. So, but I do want to show you a special way to do some of these. So, given this and the angle, it's so easy. So, question 1. Area equals half r squared theta. What's the radius? 4. It's a half times 4 squared. And what's the angle? Pi. And we tend to leave these in exact value. So it's a half times 16 times pi, 8 pi. We don't simplify it or put it, we don't put it in decimals. So we just leave it like that. I'm pretty sure. I'm just checking with the answers. First one, 8 pi. Oh, because we're finding area, centimetre squares. So they're pretty easy. 2D, well, we've got to convert. We've got a radius, but we've got the angle in degrees. So we're going to have to change that 23 degrees in 12 minutes. Now remember how we do that? Well, if pi equals 180, well, we want 1 degree, so we get pi on 180 equals 1 degree. But we don't want 1 degree. We want 23 degrees in 12 minutes. So 23 degrees in 12 minutes is 23 degrees and 12 minutes pi on 180. And remember, the pi is just going to stay there, but we'll go to our calculator. So 23 degrees and 12 minutes divided by 180, and actually we just want 23 degrees and 12 minutes as a decimal, 23 degrees and 12 minutes, and we want that as a decimal, 23.2. So now it becomes a nice easy 23.2 times pi on 180 equals 23 degrees and 12 minutes, which gives me times pi divided by 180, excuse me, we don't want that in degrees, minutes, seconds, we want that as decimal. So that's what it is in radians. So my area equals a half r squared theta. Half, what's the radius of this thing? 5.9 squared times, what was it? 0.41, 0.405. 0.405, but we're going to use that exact value in our calculator. So we go half 0.5 times 5.9 squared times my answer, because it's in the calculator. Stop giving me degrees, minutes, seconds. Right, and I'm just checking that answer in question 2. What was it? D. Yeah, 7.05. So 7.05, and it's in centimeters, is it? Yeah, centimeter squares. So that's how you do those ones. Remember, this comes out as a decimal. Oops, let's use a different colour so it doesn't look like another fraction. This comes out as a decimal. Remember, what did we get? That's it, 0.405 there. So most of these are going to be the same. You just have to find when they get a bit, if they give you the area, or what are we going? So 2's find the area. If they give you the area, so let's have a look at question 4. So let's get rid of this. Oh, come on. So question 4. If they give you the area of the sector of a circle is 20. If the radius is 3, find the angle. So area equals a half r squared theta. So if we get 20 equals a half, what's the radius? 3 squared theta. So 20 equals 9 on 2 theta. So I've just got to multiply the 2 and divide by the 9. So I get 40 on 9 equals theta. And pump that out in my calculator. 40 divided by 9. 4.4 repeater. 4.4 equals theta. Do they want it in degrees? No, they don't. And that's radians. So I'll put a little C there because we're doing C, radians. So that's pretty easy. If they give you the circumference of a circle, right? So look at 7. So I'll do 7 here. So 7. They give you the circumference of a circle. So remember, the circumference equals 2 pi r. You can do pi times d, but because we're using the radius, we're going to try and use 2 pi r. So 2 pi r equals, what do they say it is? 185. Now remember, we want the radius. So the radius is 185 on 2 pi. Okay. Find the area of a sector cut off by an angle of pi and 5. Well, remember, the area equals a half r squared theta. Well, my radius is 185 on 2 pi, so we're going to get this in exact base. So I'm going to get a half times 185 on 2 pi squared times pi on 5. Now I'm just looking at the answers to see if they give it in exact value, and they do. So this is going to be neat. I'm going to get a half times 185 squared. 185 squared. 185 squared. 34225. 34225. The 2 on the bottom will become 4, and I'll get pi squared times pi on 5. Now, one of the pies will cancel. So I'm going to have a pi on the bottom. And I bet 34225 goes into 5, or 5 goes into it. So let's go, we'll divide that by 5. We get 6845. So on the top, I'm going to get 6845. And on the bottom, I'm going to get the 2 times the 4, 8, and I'm going to have a pi. And that's the area, units squared. They didn't give us an amount, did they? No, they didn't. Oh, no, millimetres. It's millimetres squared. Okay. Right. So most of them are the same. I want to do question 9 as well. You go and have a go at it. You just come back if you're having trouble. So here I go with question 9. Find the area of a sector if the length of the arc of that's with the radius of that and the length of the arc. Now, you can overcomplicate this. This is really easy. So 9. Remember, the length of the arc is r theta. Okay? So what's the length of the arc? 4.2. So 4.2 equals r theta. Now the area equals a half r squared theta. Now if I just rewrite that slightly differently, that's a half times r theta. Yeah? We know what r theta is. It's 4.2. So all I have to do is go a half times the radius. Well, what is the radius? 5.7. And r theta, they've already told us what r theta is 4.2. And this is a really cool way to do this problem. So what do you get? And there's no pi's. It's so easy. So I get equals, and I just pump it into my calculator. So 0.5 for half times 5.7, was it? Times 4.2. 11.97. That is so easy. So what was that question 9? I'm just checking. 1.97. What units were in? Centimetres squares. Question 10 is similar. They give us the area of a sector. You go and have a go at it. And the arc length is that. Find the angle. So go and have a go. If you're having trouble, come back. I'm going to do question 10 here. So question 10. And I'm going to do it in a different order. It tells me to find the angle, then it tells me to find the radius. I'm going to find the radius first because area equals a half r squared theta. And they tell me that's 3 pi on 10 equals a half r times r theta. I'm going to put that there because you watch what happens. And they also tell me that the length of a sector, which equals r theta, is pi on 5. So pi on 5 equals r theta. And look again. There's r theta, there's r theta. So I can put pi on 5 directly into that. And I'll be able to equate r. So if I sub, I'm going to write what I'm doing so you follow. Sub r theta equals pi on 5 into, I'm going to call it equation 1. Here we go. I get 3 pi on 10 equals a half r times pi on 5. Now, I'm going to multiply that 2 and that 5, so I get 3 pi on 10 equals r times pi on 10. Well, it's pretty obvious that r is going to be 3, but what do? We're going to multiply that 10 across, 3 pi on 10, multiplied by the 10 and divided by the pi equals r. Well, what happens to the 10s? Come on. they cancel, the pi's cancel, which means r equals 3. Now, if I know r equals 3, I'm just going to now use this equation here to find theta. R theta equals pi on 5. But 3 theta equals pi on 5. I'll just put the 3 in. I'll put this 3 in here. Therefore, theta equals pi, divide the 3 on 15. And I'm just going this, it's question 10. No, so easy. Okay, the last one I want to do is question 14. And I really only want to do A, C and D, but I'm going to do B. I can do A, C and D so quickly, so easily, and I'll do B separately. Because I don't know why they've put B in there, but anyway. So what do we got? We've got this, I'll create some space first. Okay, so question 14. A. So find the area of the sector. Too easy. Area equals a half r squared theta. R is 4, so a half times 4 squared times pi on 4. Which will give me a half of 2 pi. I'm just double checking. 14. Yep, 2 pi centimetres squared. You can do that on your calculator, but all I did is I went, 4 goes into that once, and a half of 4 is 2. Okay. Remember, I'm going to skip B. I'll do B over here in a minute. There you go. B's coming up. Find the length. Find the exact area of the triangle ABC. So they just want me to find this area. So area equals, well, I know that they're the radius of the circle, and I've got pi on 4 in the middle, so I can use a half AB sine C. A half AB sine C. So, well, it's a half times 4 times 4 times sine pi on 4. Now, I know exact value, and it's on my reference sheet. So if that's pi on 4, that's 1, there's a root 2, that's 1 on root 2. So it's going to be half times 16 times 1 on root 2, which gives me 8 on root 2. I possibly should rationalise that. So that's why we do all that surd work, and multiply by root 2 and root 2, which will give me 8 root 2 on 2, but 2 goes into 8 4 times, so I get 4 root 2. And that's the area of the triangle. We in centimetres, centimetre squares. Therefore, D, find the exact area of that minor segment. Okay. Now, the minor segment, they've shaded it for us. That is the minor segment. When you cut a chord in a circle, you get 2 segments. So you get the minor segment and the major segment. So if we've got another circle here that I can just show you. Okay, so if I drew that there, that's the minor segment, and the rest of it is the major segment, because it's a bigger one. You got the little one and the bigger one. So the area of the minor segment, well, it equals the area of the sector minus the area of the triangle? Well, that was 2 pi minus 4 root 2. That's it. That's the answer. Okay. B was a little bit harder. I want you to think about B. We've got to find the length. So I'm just going to draw the triangle for B. So remember, there it is. And we've got to find this distance, BC. Well, that's A. Now, this is an isosceles triangle. So I'm going to draw an altitude. All right, so I'm going to get a right angle triangle. And this angle here, which was pi on 4, now gets split. So this will be a half pi on 4, so that's going to be pi on 8. All right, and I've got to find this distance. And I know that this distance and this distance are the same. So I'm going to call this x. I'm going to find x, because I know that's 4. I'm going to find x, and I'm going to double it. So therefore, sine pi on 4. Okay, so I'm going to redraw this triangle so you can see it. So here it is. Oh, sorry, and even then I've made a mistake. That's pi on 8, and that's x, and that's 4. And there's a little right angle. So straight away I've made a little bit of a mistake. So that's sine pi on 8 equals x on 4. So 4 times sine pi on 8. And if my calculator is in radians, I'll be right. So and the trouble is though, and I want to do this all, okay. So 4, where's my calculator? So I have to put my calculator in radians. Is it in radians? Let's just double check. And 4, put it in radians. Okay. So 4 times sine pi divided by 8. 1.53. 1.53 ... equals x. But we don't want x, we need BC equals 2x, which equals 2 times 1.5, bloody hell, 53 ... which equals, I'll just times that by 2, 3.06. 3.06 ... what do they want it to? 1 decimal place. So 3.1 centimetres. Okay, well, you should be all right with those. They do get a bit harder, but if you're having issues, email me, and that's one day's work.